Okay, remember what we learned in the last video? That is electric potential or voltage. If you do not have the idea what is voltage or what is electric potential, you can always click on the I button and watch my last video on voltage or electric potential. So let us move ahead. But before that, let's just recap once. So what was voltage? Voltage was equal to work done per unit charge, and by symbols it can be written V equal to W over Q. Now today we are going to learn what is meant by potential difference. In an electrical system, the potential difference between any 2 points in an electric field. So there are 2 points and there are two charged particles in an electric field inside the electric field. So in any electrical system, this thing is much more useful than the absolute potential at any point. So what is absolute potential? Absolute potential means the thing that we learned last day. So if there is somebody in infinity and it is coming to this point, that is called the work done to bring that charge from infinity to any point inside the electric field is called absolute potential. But that is not much useful in physics. What is more useful is in any system, if you have 2 points inside an electric field and you have to bring them towards each other. So let us consider 2 points A and B. So they are inside an electric field, both of them. And how is this electric field created? Who created this electric field? There must be another charge. So let us take a charge Q who actually created this electric field. Now, if the work done in bringing some other charge small q who is at infinity, where we will bring this charge small q from infinity to A or to B. So the work done to bring q charge from infinity to point A is represented by WA. The work done to bring the charge from infinity to the point B is represented by WB. So if the work done in bringing charge Q, this one, from infinity to points A and B are represented by WA and WB respectively, then what can we write? Then we can say potential at point A is VA because we represent potential with V. So since it is in point A, we are writing suffix A next to V. So what is the potential? We know V equal to W by Q. So VA means the potential of point A will be WA by Q. Now Q is constant because that charge was at infinity. Okay, the value of the charge is fixed. What about the point B? Potential at point B will be VB and the work done will be WB. It will be of course different from that of the work done for bringing the charge to point A. So it becomes WB. But the value of the charge is same, so WB over Q. Now potential difference between B and A. What is the difference? Difference means subtraction. We have to do subtraction to find out the difference. So the difference in potential between point B and point A will be VB minus VA, and that will give us WB over Q minus WA over Q. That equals, so if we take Q as common, it becomes WB minus WA. Thus, the potential difference of the 2 points in an electric field is defined as the amount of work done in bringing one unit positive charge from one point to another. That is the potential difference between 2 points in an electric field. Now let's come to the SI unit. If WB minus WA is 1 joule, of course they are the work done. So their units will be in joules. So if this work is 1 joule for a charge of 1 coulomb, so what will be the potential difference? VB minus VA. That will be equal to 1 joule per 1 coulomb. And that gives us, you can write it as 1 JC to the power minus 1. You can write it as 1 volts because in the last video we saw that joule per coulomb is also known as volts. So volts can be written in its symbol, that is V again. So what is the SI unit of potential difference? That is volts. If I tell you to define 1 volt, what would you write? If 1 joule of work is done in taking 1 coulomb of electric charge from one point to another, then the potential difference between those 2 points is 1 volt. Simple. Measurement of voltage. How do we measure the voltage or potential difference between 2 points? Well, voltage or potential difference between any 2 points inside an electric field is measured by using a machine or a device called voltmeter. It looks somewhat like this. There are several types of voltmeter you'll find in the market. So this is called a voltmeter. So let us revise some of the key points on voltage or potential difference. Firstly, voltage is measured by the device called voltmeter. Secondly, it is a scalar quantity. So you have learned a little bit about scalar and vector quantity. We can discuss more about it in detail in the other videos. Scalar quantity is a quantity that has only magnitude, and vector quantity has a quantity that has both magnitude and direction. This is the basic difference. So voltage comes under the category of scalar quantity. Voltage is denoted by V, capital V. Its unit volts is also denoted as V. So do not get confused between which V is voltage or potential difference and which V is the unit volts. And what is the SI unit? Of course, it is volts. So that's all for today. See you on the next video. If you have any queries regarding voltage or potential difference, you can write it down in the comment section. Till then, goodbye.